When you're writing Java code, it's very important to make sure that you understand how logging and debugging works in Hadoop. In this chapter, we're going to look at debugging in distributed environments. We're going to take a walk through the log files. We're going to look at their locations and purpose, and we're going to discuss some debugging tactics that we can use inside of Hadoop. So first up, let's talk about distributed debugging. When you're running code on many individual mappers and reducers, it's a whole lot more difficult than debugging in a single machine. You obviously can't step through the code, and when you're working with very large data sets, it also exposes tons of missing and malformed records. Some of the best practices to help you deal with these unique scenarios in a MapReduce environment: number one, code defensively. Don't assume that the data is in the format or the types that you expect. You want to double check your data types every time before you go through and start processing them. Make sure that you use try and catch to either ignore or log malformed data. You don't want missing or malformed data to cause your whole job to give up. Obviously, working in an integrated development environment or an IDE like Eclipse or NetBeans is highly recommended. A lot of these IDEs also integrate the local job runner mode directly into the IDE so that you can run in local job runner mode, which we know is a lot faster. And you can then perform your local job runner mode, then pseudo-distributed, then fully distributed code walkthroughs. Obviously, doing tests with small representative data sets, small representative production cuts of your production data. When you're building these sample data sets, you want to make sure that you fully sample through the entire source file. So rather than just getting the first 1 or last 1% of a file, instead maybe try to pull out every 100th line or every 100th key value pair. Obviously, writing unit tests is going to help you a ton here, and Hadoop provides us with a constantly evolving and rapidly progressing test suite called MRUnit to help you at least test your mappers and reducers. And you can find more about that at mrunit.apache.org. When you need to log information out, our old tried and trusted friend, the print statements, simply don't work in Hadoop. The output, instead of going to logs, is going to go to the task tracker logs on which the individual mappers ran, and that's not going to help us a whole lot. So for every job, Hadoop does retain logs. It retains aggregate job level logs in HDFS at the location of the output directory you specified for the job in a directory that you've probably already seen called _logs. That directory also contains the XML configuration file that was submitted by the Hadoop jar command. Each individual task tracker also maintains their logs at var log hadoop 020 mapreduce/user logs, and then the name of the task ID, and syslog underneath that directory. So if you want to go in and see the actual logs for each individual task tracker, you can always go into each individual machine. These are both actually accessible via the job tracker web GUI and the Hue user interface. Be very careful what you're logging in Hadoop. We'll see in the upcoming code exercise that we can actually, by logging too much information, end up with a much larger output data set than even our input data set. And if we're talking our input data set is hundreds of gigs or dozens of terabytes or possibly even petabytes, a whole lot of logging information could actually completely fill up your HDFS cluster if you're not careful. The log files are not automatically cleaned up for you. And it's important, if you're administering a cluster, to make sure that you sandbox new users and probably all users and give them a quota using HDFS quotas to make sure that they simply, by doing something silly like logging too much information, cannot bring down your entire cluster. Be very selective in what you log. We're going to see in our exercise that we're not very selective, and that could cause problems. For logging, Hadoop uses the old Java tried and true log4j framework. And to use log4j, you simply need to add 2 imports at the top of your file, the log4j.level and the log4j.logger. And then you get your logger back out with a call to the logger.getLogger and specifying, for example, if you want to get a logger for your mapper class, going through and grabbing the class for your mapper and getting the name. And then once you have a logger object, you can simply then start logging by specifying the log level that you want to output this data for. For example, here we're specifying debug, and then the message that you want to output back out. And then this message will be written back into the task tracker logs. So logging only happens if we've turned on a log level inside of Hadoop. Hadoop uses the standard Java log levels. The 5 log levels trace through error, with trace being the lowest level and error being the highest. Error, honestly, in Hadoop doesn't matter a whole lot because if you encounter an error, your job is probably going to fail. After you get an error in Hadoop, your entire job fails. So we typically use debug. You can specify the log level either statically in the etc Hadoop conf log4j properties of the machine where the job is running. So we could simply go and specify a line like this to set our mapper class to the debug level. And obviously this could be very useful if we're only interested in debugging one single class. More frequently, we'll typically do this in the code. So at the top of that mapper code, we would go in and do something like logger.setLevel. And we'll see in our exercise, we'll actually do it in the partitioner. So let's go ahead and hop over to your setup environment. We should either have a quick start VM or you might be using the Cloudera Manager 4-node cluster. Here we're using the quick start VM. Let's go ahead and open a terminal and move this out so we can actually have 2 terminals side by side, and open a second terminal and space this out appropriately. And you should have already pulled down from previous exercises our code and data. So we're going to go into the code and data and the code directory and the logging directory. And let's look to see what we have inside of here. We see that we have several files, a logger partitioner, and our standard word count driver, mapper, and reducer. The logger partitioner is actually where we've set up some logging. So let's take a look at this file itself. And we're going to open it with Emacs, word count logger partitioner Java, Control X1 to get a single window view. And we see here at the top of this file, we've set up our log4j packages, so our level and our logger. Then we've gone in and set up our logger. We see that we're pulling in our word count logger partitioner, the file itself right here, and grabbing its class name, and we're setting up this logger object. And now down inside of our code, we're actually setting up a logger warn message. So this will happen if we're at the warn level, and we're going to say that we have a valid key and we spit the key back out. So let's say in this example, when you were writing your code, you weren't getting the arrays as list to actually show the key itself. Right here, we need to do a .toString to convert the key to a string, but we didn't do that. And we want to see in our exercise here if we do in fact have a valid key coming in to see if our code works. So this code is what you could use to debug that and test and see what's going on. So we haven't edited this code at all. This is the exact same code with the exception of the logging information that we've added back in here. So let's go ahead and compile all this code. Again, we do our trusty Java C, passing it the class path, and then in backticks, Hadoop class path. And we're going to compile all of our .java code. And then now we're going to jar our file up. So we issue a jar cvf to bring our jar file together. And let's call this one logger.jar. And we're going to jar up all of our .class files. And if we look and see what we have now, we obviously have our logger.jar and all of our class files were created. So when we run this code, we would expect to see our partitioner logger output some information back into HDFS. And let's see if that's what actually happens. Let's go ahead and run our Hadoop job submittal command. So we're going to go Hadoop jar, give it the name of our jar, logger.jar. The word count class is what contains our main method. And again, we're going to use input data / Shakespeare. And let's actually open this window up a little bit so we can see the command on one single line. And then in this case, let's actually write our output to output logger in HDFS. And push enter there and let our job start running. And let's make sure that it's off to a good start. When we see this, we can be sure that it's passed all the sanity checks. So as this is running, let's go ahead and pop open a web browser. And let's go to our job tracker web GUI, which is on port 50030. You should just be able to type that. And from previous exercises, you should see that localhost :50030 will get you there. And if we scroll down, you might see a different number of completed jobs, but we see that our running job is this job right here. And if we refresh this a couple times, we should see the mapper percentage increase and keep refreshing. Let's go ahead and wait until it gets up a little bit. So we've got 4 map tasks and we're at 50%. So we should at least have one mapper's output written back completely into HDFS. And if we click through onto the map tasks and then we click on map right here, we see that we do in fact have a couple tasks complete. And let's go ahead and click on one of these tasks. And you can see that we have a task attempt that happened on some node in our cluster. In this case, we're running in a single machine. So all of the map tasks happen on a single cluster, on a single machine. And if we look over here on our third to last column, we see that we have task logs. Let's just look at the last 4 kilobytes of this. Here is the data that we spit back out from our partitioner logger call. So we see that we do in fact have valid keys coming back out of here. This obviously proves that our logging works, but we know that for every key that we got, we output all the data back out. So if we go and look in Hadoop, let's look at our input data set first and see how big that was. And let's go to Hadoop fs-du to show the disk usage of input-data/Shakespeare. So this will tell us how large our Shakespeare data set is. And again, it's hitting HDFS, so it's a bit slow. We can see here that we've got probably maybe 4 megabytes of data that we've had for our input data. Now let's actually go and look at our output data. So if we go back to our job tracker and open up that port 50030, let's just get our job ID again. And the one that completed was this one right here, 10040. And because we're on a single machine, we can also just simply become the user, so sudo su-, and then we can look for this directory inside of our local file system. So let's do a find, type F, and grep against this job ID. And I made a silly mistake here. Let's go back and run this command, our find command, against the top level directory. Find, type F, and then grep for our job name. And we see a whole bunch of data was written to this machine. Let's go and look through this data one by one. So we see that the MapRed local user logs is where all of the data was saved for our output error, for output logging. So this directory is the one that contains all of our logging information. And we also see a couple other things in var log Hadoop 020 MapReduce, the job directory. This is the actual config file that was used, as well as all of the history for that individual job. So let's actually look and see how much data was generated in this MapRed local user logs job directory. And let's copy that out with Control-Shift-C. And let's do a du on that directory. And Control-Shift-V to paste it back out. And we see that we actually have quite a bit of data coming back out of here. So I think this is in kilobytes. I believe that we output in that whole directory 75 megabytes of data back out. So we can see that given our input data of about 5 megabytes, we output way, way more data than we had going into the program itself. So again, this is that danger that I was talking about. So let's actually take a look at this. Let's get out of this terminal and close it completely down. And if we go back into our code, close down the browser, and cd into code and data, and code and logging, the whole reason that we output so much data is because we simply didn't limit where we were doing our logging. And so if we open this file back up, let's take a look at why we generated so much information. It's because we didn't wrap this in any sort of if loop. So we're outputting for every key value pair, we're outputting a key value pair. And again, this is a very common mistake with novice Java developers that are new to Hadoop. So be careful if you're doing something like this, that you simply wrap it and maybe you're only outputting, in this case, we only really needed to know if maybe 5 of the keys were valid. And then that could give us a good clue. Again, the way to fix this code is to simply come in here and do a toString call on this and this parameter. And that would fix our code. But this code as it stands right now is broken. And you can see working code in the partitioner directory instead. We're not going to save this file. We'll just go ahead and close it, push no here, and exit yes, and clean up our environment for the next lesson. I hope you enjoyed that tour of the logging and debugging basics. We should now have a good clue as to how to get logging and debugging accomplished in a distributed environment. We should know some best practices, and we should be familiar with the various log locations and what is stored in both HDFS and on each individual task tracker itself.